Our next discovery takes us on the quest to find the smallest pieces of matter in the universe. First, the electron was discovered, then the proton, and finally, the neutron. Science now had a new model of the atom, the tiny building blocks that make up all matter. And once accelerators were developed that could slam subatomic particles together at nearly the speed of light, dozens of new particles broke away in the process and were discovered. So many, in fact, physicists began to refer to them as the particle zoo.
In the late 40s and early 50s, when the discovery of so-called strange particles began, I got very interested in that. But it was an offbeat field. One wasn't encouraged to work on that.
American physicist Murray Gell-Mann began to see patterns in the bewildering array of all the new members of the particle zoo. He used common characteristics to divide particles into different families. In the process, he isolated the smallest components of the atom's nucleus, the very pieces that protons and neutrons are built from.
As a theoretician, I couldn't, I suppose, really discover new things, but I could propose them. And if they turned out to be right, you could call it a discovery in a sense. What I did was to propose that the neutron and proton were not elementary, as everybody thought, but were composed instead of smaller particles called quarks with some very bizarre properties.
Gell-Mann's quarks did for subatomic particles what the periodic table did for the chemical elements. And in 1969, he was awarded the Nobel Prize for Physics. His classification of the tiniest bits of matter brought order to the chaos of the particle zoo.
I thought that the sound, quark, was a good sound for these fundamental constituents. It sounds like a good name for the fundamental constituents of neutrons and protons, mesons, quark. But I didn't know how to spell it. I thought maybe K-W-O-R-K. But then, perusing James Joyce's Finnegan's Wake, as I do once in a while, I noticed the line, 3 quarks for Muster Mark. And I thought, 3? After all, that's a very important number for quarks. And maybe I should spell it Q-U-A-R-K.
While Gell-Mann believed quarks to be real, he never expected anyone to find one.
Some of the earliest evidence that the quark idea was correct came from experiments by friends of mine at the Stanford Linear Accelerator, in which electrons were scattered off protons. And essentially, what they were doing was taking an electron microscope picture of the proton. And sure enough, there were the 3 quarks.